Hello, this is going to be our presentation on options for seismic monitoring for the Hunga Tonga Hunga Hapai region. Uh, we should be looking to implement a few methods that aren't too expensive or unreasonable in order to give the people there an early warning and try to safeguard against some of the effects of natural disaster from the uh, aquatic volcanoes. Um, Enjoy.
Hello, my name is Emily Gershny, and I contributed to the information presented on the slides as well as organizing.
My name's Sai. I help put together the PowerPoint and find monitoring methods.
My name is Ronan. I helped with a lot of formatting of the information and a few of the monitoring methods, and I'll be presenting it all to you today. Before we get into the specifics of what seismic monitoring methods we're using, a brief overview of why they're important. Is there any way we can listen in on any seismic information, and using this we can figure out what will happen before it happens, giving people in threatened areas of volcanic activity a head start or a warning, and it could end up saving a lot of lives. Many volcanoes have a lot of systems, but the vast majority of volcanoes are actually submarine, and those present a lot of unique challenges which may need special attention to detail when discerning which methods to use. Satellite-based monitoring systems offer a lot of unique ease of use after they're set up, as it doesn't require much maintenance, and they can end up providing a lot of useful information, such as GPS systems with fine-tuned trackers put in strategic locations to measure very, very small changes in the surface of the ocean to try to track what seismic activity is happening underneath. Or more broad methods like INSAR can be used to get a large data on range over a huge swath of area like land. And that can end up being sometimes even more useful than the more precise information. Sometimes the water can end up actually creating some disturbances in the information gathered from the satellites, so other methods may end up having to be used sometimes. While the unique challenge of getting the signal through all of the water does definitely make it less reliable than some other ones, the benefits they do provide, such as the incredibly wide coverage area from the INSAR, or the real-time data and monitoring, and the really fine-tuned stuff, is definitely worth at least trying it. If it ends up proving more trouble than it's worth, it may be useful to stick to some other ones, such as ground-based monitoring systems. These systems are useful as they end up circumventing the atmospheric and water interference by usually being either retrieved or having caches that are retrieved every once in a while, or sometimes you can have like a boat monitored nearby that can end up getting the signal there instead of having to go all the way through the water and then through the atmosphere. And they can take the form of static monitors, geophones, or tilt meters, usually the latter two, as the former is more for after the event has already happened and warning the future. Geophones and tilt meters are more precise instruments that gather specific information in a smaller area, but that information is very, very useful for determining what is happening geologically and seismically in that area, and if any abrupt changes are happening that should be studied further to warn of impending disaster or any other situation. As stated, there are a number of benefits, but the main weakness is that you can't have too many of them, as with something like the satellite information, you could get a very, very wide range of data across the entire volcano. But with these, it's definitely fewer locations. But with strategic placing, these downsides can be offset and you can end up with a lot of benefits. Gas emission measurement is also a very useful tool to add to our arsenal of seismic monitoring methods. It measures the gas released from the underground magma chambers of the volcano as it proceeds closer and closer to eruption. And although it's easier on above ground volcanoes, submarine volcanoes do have options. There are a lot of areas for trackers to be, but they end up monitoring the concentration of gases like carbon dioxide, sulfur dioxide, methane, or hydrogen sulfide. And using these data, we can see if it deviates from the norm, and then if that happens, we can compare that with other things to predict eruptions. Infrared monitoring systems are also incredibly useful. They're non-invasive compared to the other ones, except for some of the satellite methods. And a lot of times it can be very cheap and done often, and it lets you get a lot of information over the entire volcano, over a lot of the heat generated inside, bleeding through the crust and showing on the outside. It can be one of the best warning signs that a volcano is nearing an eruption or something of that caliber, and there's a few methods which can be used to get this information. There are a lot of satellite-mounted thermal imaging systems, but those tend to be very expensive, and in the likely event that we don't have that kind of funding, we'll likely rely on drone-mounted thermal imaging systems, which can do a very good job anyways and are incredibly cheap and budget-friendly. While it definitely would be our main source of information, borehole monitoring, if funding allowed, would be a useful addition just as a form of redundancy. It does give useful information, although implementing this is definitely expensive and inefficient and hard to do underwater, but it's possible.